Okay, in this class, we will talk about the construction of rebar formwork. Before class, we assigned a pre-class discussion. Ask classmates to investigate the types of rebars on our training basis rebar platform. Most of the classmates have completed the task. Let's take a look at the results we have completed together. Many classmates said that our rebar platform has stressed steel bar, erection bar, or constructional reinforcement. Of course, there are also classmates who said there's bent-up reinforcement, straight reinforcement, includes pre-stressed reinforcement, distribution reinforcement, etc. In fact, the type of rebars we learned in the previous class was one of the knowledge points from our last class. By functions, we can categorize the rebars into constructional reinforcement, also known as an erection bar. For the erection bar, we have stirrup and compressive reinforcement, although the latter is also under compression, but it is essentially an erection bar. Its main purpose is to stabilize the structure, and its main function is to provide support. The stressed steel bar mainly refers to the tensile reinforcement under the reinforced concrete. Tensile reinforcement is also, for example, bent-up reinforcement, and the straight reinforcement below the straight reinforcement under tension. The straight reinforcement that is under pressure belong to the erection bar. This is one point. Let's continue. Actually, we gone to the rebar platform to see the rebar and actually investigated our rebar. Here is a reinforced concrete member. Let's have our classmates draw the shape of the rebars. Before drawing, we need to consider a few questions. Why do we use rebar this way? For example, this rebar, usually for our rebar or our drawings. Like here is an elevation drawing. In the elevation drawing, in order to reflect the shape or quantity of rebars, we drew a profile. We drew a middle section on the middle profile. We know rebars has compressive reinforcement on the top, tensile reinforcement below, and stirrup around. So why do they make another profile? Why do we need one more? Does anyone know or want to answer? Okay. Let's invite this classmate to answer. Why do we need to make two profiles? I think this makes it easy to observe the shape and structure of rebars. To better observe its shape and structure, a little bit, right? In fact, if this rebar has no bent-up reinforcement, the bent-up reinforcement here, then we can just use one profile. So why do we need to use two profiles for this rebar? Because this is a stressed steel bar. Have you noticed the stressed steel bar? There are 4 stressed steel bars below. It's changed here. If we just make one profile, it can't reflect such changes, right? We still need to make another profile in the place where the change has taken place to explain how it has changed. For example, with bent-up reinforcement, you need to bend 2 or 3 rebars here, or here you need 1, 2, or 3 rebars? We don't know either. From the profile here, we know that. We know there are 2 rebars going up here. If you look from the side, 1 rebar going up from here, and 1 rebar going up from here. This is why we need to make 2 profiles.